Welcome back to the Rakuten Booth, ladies and gentlemen. Next up, we're going to be treated to a showcase of we will learn how Rakuten's brilliant engineers have created artificial intelligence and machine learning algorithms that can create energy savings of up to 25% via an ORAN-compliant RIC platform. This algorithm allows smart antenna use that allows sites to be controlled with ease. It's now my great pleasure to welcome our next speakers for this session. Medithe, the Chief Data and AI Officer of Rakuten Mobile. Please give us a big hand for Madhu, ladies and gents. And Petrit Nahi, the Chief Advisor of the Technical Office for Rakuten Mobile. Thank you very much.
Thank you. Thank you, everyone. Good morning, and thanks for joining today. So, as James introduced you, we're going to be talking about what we're doing with RIC, with AI, and how the two come together. And the objective of what we are doing is really how do we address the demands of the digital age and the emerging technology. I'm going to start talking about AI first because that's one of the hot topics. And what does AI really allow us to do is to make better decisions, more accurate decisions, faster decisions, consume a lot more data, and take that as an input into AI. So AI in Rakuten Mobile we've used actually since the inception. So in 2019, we actually set up the department in Rakuten Mobile, which Madhu and myself were leading. And this was focused on AI and data science and how we apply that in making sure that we achieve automation in network, but also how do we drive towards network autonomy. So AI is something that we have used. We've done a lot of application over the years, over these last 5 years. And the next kind of pillar in that drive towards achieving autonomous network is the openness of the network itself. So being able to actually actuate what decisions are being made into the network itself. So Open RAN is what gives you that scalability, that ability to innovate, and that ability to control the network through standard interfaces that are critical. Now, coming back to the main kind of topic of what we are talking about today here is the intelligent control, and with focus on RIC, on RAN, on the RAN part of intelligent control. And we see this as a critical means of actually actuating or implementing the decisions that are being derived through AI and through the data that is being processed. So RIC itself provides you that means of controlling those decisions and how they are implemented in the network itself. And it's critical component in terms of actuating those decisions and implementing them in near real time and non-real time as well.
Yep, thanks, Petrit. So as Petrit mentioned a few points, we have started this entire activity in 2019 onwards. So we know that everybody knows that we have started. So it's we have come up with a new kind of deployment. We have distributed everything, and with respect to nodes as well as hardware, and we went into the software domain prospect to the entire telecommunications. So when we went into the virtualization, deploying our solutions, and we believe that automation is the key essence. And from there, we have made our pillars with respect to AI and data science perspective. So last 5 years, we keep working on how we can enhance ourselves and how we can emerge ourselves in most advanced AI technologies. That's what we believe, because we are always into the cloud and virtualization network. So that's where made us the key success where we can deploy our solutions mainly in as well as software perspective or efficiency on hardware perspective. That's what we're driving today. So mainly what we're talking here is why we need RIC. So as you know that we have a lot of AI algorithms are there. We have a lot of other applications are there which are working independently. Be it SON, be it OSS applications, be it ML applications or some automated applications. But what we think is everything should be synchronized. It has to be coherent to each other so that we can drive towards efficiency and optimization towards the end user prospect. That's what Rick is going to do us as an intelligent controller. So today we would like to show how we're trying to improve the customer experience along with the efficiency in the network and how we can do the cost optimization. That's what Rick is going to do for us. And that's what Rick is the solution which enabling AI solutions along with other solutions, merging together and bringing the efficiency towards the end user and as well as cost efficiency. Next.
Okay, so talked about the RAN part, and we see the interaction between AI and Rick. So on the RAN part and the implementation of the applications and their streamlining through Rick, as Madhu said, kind of Rick as an enabler, as something that provides that coherence of the applications that are actually making changes in the network. But one of the things that we have been doing over these last 5 years as well is that, this intelligence or this intelligent decision-making process that is targeted with Rick on the RAN part needs to be extended beyond Rick or beyond the RAN piece. And here we've done a lot of work in trying to see how we can bring together Rick and NWDAF use cases. So really driving towards network intelligent control. So not just on the RAN part. RAN part obviously is the most critical part of the network, but we're looking at beyond RAN, how do we control the network? RAN is also the most challenging part, as you all know, but we've worked on use cases where we see this working together end to end between the RAN and the core network as well, and addressing basically use cases like congestion control from RAN to core, etc.
Adding to that, just maybe we can go. So the main use case, what we see, like basically zero touch service management, is trying to bring, and the crux of this entire solution, how we can integrate the RAN towards the core element, mainly NWDAF. NWDAF, we know that it's a 5G, 3GPP defined element. But this network function, we wanted to integrate with RAN. Basically, whatever the trainings, the models which we have derived from the core, we're trying to integrate those things in the RAN segment via Rick, so that we know who are the users are consuming more data, who are the VIP subscribers, who are what we need to do optimize with respect to the RAN using the core element. So this is the step towards V2X kind of applications or high latency, low latency kind of applications, or eMBPS kind of applications. That's what we're trying to integrate different network elements with and like code and RAN together. That's how we're trying to compose here. So now, if you see our Rick platform high level, you can see the right. So we have our SMO framework. Can you hear me now? Yep. Yes, yeah. So now, if you see at high-level architecture, how we have deployed our solutions, we have an SMO where we have our own configuration management, FCAPs. Basically, SMO is service manager orchestration function, which having all PM stats, configuration, fault management, all the network related configuration there. At the same time, our non-real-time applications getting deployed in the same SMO framework. So we have our own data lake. So whatever the probes data which we're capturing from the network elements, we're trying to train in our data lake using our own in-house data platforms and AI platforms where our AI models are getting trained over there. And we have basically R1 interface. Of course, standards are still keep evolving with respect to the R1 interface perspective. But yes, we have looking into the closely working with the standards perspective, especially with respect to working group 2, working group 3, as well as working group 2 O1 for O1 interface perspective. And for model training, as well today, for the application which we're trying to show, we are using R1 interface where we can enable RApps, where we have done some little bit customizations. But the overall solution which we're trying to showcase here is not only limited to the 5G or O-RAN kind of thing. We're also looking towards how we can integrate this solution to a 4G solution, because we know today 95% of the data and across the globe is going towards 4G. So we are not limiting ourselves only to the 5G or advanced 5G or 6G kind of things. But what we want to do is, with the use case of the rig, we can do our own customizations. That's how Rakuten is working towards. So that's what, we are further coming slides, we can see that how we can integrate this solution to 4G solutions as well.
Okay, so as Rakuten Mobile, we are effectively a consumer or a customer for a rig platform. And this is what we are driving to have within our network. And we're working on developing this together with Rakuten Symphony. And we have achieved critical milestones, and we have capabilities now both on non-real-time rig and near real-time rigs. So from ability to actually manage the applications, onboard them, and the support for the different interfaces that are in the standards, so that we can also support third parties and work with third parties as well. So not only application developers, but also RAN vendors that are supporting the Open RAN interfaces as defined in the standards. The capability is basically to support that multi-vendor interoperability. So we want to onboard applications from third parties. We want to kind of use best-in-class applications from others. But at the same time, we are also, as I said, we have spent a lot of time over the last 5 years in building different models using AI and ML. We want to basically also integrate those and convert them into our apps. And we have some our apps target use cases that Madhu will tell more about.
If you see that the applications like impact compensation, energy savings, remote electrical tilt, and sleeping cells, these are the some of the our signature algorithms. Out of around, we have around close to 120 plus applications. So this impact compensation is something which is very critical with respect to the operations perspective. When we have any kind of coverage hole perspective, or if there is any outage in the network, immediately we should take an action with less than a couple of seconds. That's where RIC will come into the picture, because we train our algorithms with petabytes of data which we have in our network. A billion parameters we're going to train, and we have our own hyperparameters tuning will be there. So whenever we see this is the particular site where we see the impact is ongoing, immediately our model will tell the required parameters to upscale the particular cells to do the impact very, very less. That's what impact compensation signature algorithms with respect to RIC. The same way, we're talking about energy savings, because we know that 20% of the cells, or 25% of the cells in the network carrying maximum 60 to 70% of the traffic in the network. So we'll talk those things in the next coming slides. But another thing is remote electrical tilt, which is $1 billion solution if you go into another vendors or another customer's perspective. But this completely in-house applications which are made with the data what we have. And then the sleeping cell detection, this is basically one of the must needed applications in telecom operations, because as we have hardwares, as we have different applications running in physical layer, MAC layer, and RLC layer, we see that some of the stacks will get hit and leads to the sleeping cell in the network, which eventually leads to the user efficiency. So these are all we already onboarded in our RIC platform, and that's how we're driving in Rakuten Mobile.
Okay, so now we're going to walk you through the energy savings use case that we have implemented and we have demonstrated in an OTIC lab. And we'll walk you through the different stages that we went through and the components of that use case. So we'll start obviously with the AI ML part. So the first part of it is the model training. In Rakuten, we have an AI platform. That AI platform is integrated and interacts with the RIC platform. So the interface between the RIC platform and the AI platform allows you to train the models and then use the inference from those models in order to make decisions. So the R app itself, which is residing in the non-real-time RIC, will interact with an AI model, ML model that is residing in the AI platforms through a standard interface. Our NSC is still working on integration between the two, the AI/ML framework and the RIC platform, but we're following those closely, and we're basically trying to implement the standards and implement the solutions so that it supports this capability of integrating the models seamlessly in the RIC platform itself. So the example here that we will see a video of. So this is the AI platform in Rakuten Symphony. So if you go to SimWorld, you will see the AI platform. It has different components. So here we obviously use the AI platform not only for integration with RIC. We have a lot of other different models and different things that we do in the AI platform. But one of the key things when it comes to RIC is the pipelines that you're going to see here now being created. So in this case, basically we created two pipelines. There's the pipeline to train the model first. So you're training the model, you need to update that model. So the training basically is based on traffic patterns that you see in the network. And the idea of the RAP basically is to use that information or to infer that information in terms of setting a policy then for XApps in order to take action accordingly. So these are the two pipelines that have been created for this RF channel reconfiguration use case. One is for training, so you need to send data to the model on regular basis in order to train based on the changing traffic patterns. And then you need to infer on regular basis what is the policy that you can set for that particular cell or network element. So once we had the model developed basically, and we had the RAP also developed the tool. So the next step is really to onboard the next step is to onboard those RAPs and XApps into the RIC platform. So here we are basically showing the key part of how do you manage the apps, RAPs and XApps, how do you onboard them, how do you take them through their life cycle and deploy them in the network itself. So you can see here there's certain prerequisites required for application onboarding. So you have that information. That information has to be available so that you onboard the apps and deploy them subsequently. So a slightly different path for XApp onboarding to RAP onboarding and so on. Here we have a short video illustrating how that process actually works. So you need the descriptor file. You specify that descriptor, you specify the name of the app, and you then essentially specify the different parameters, and you need to obviously upload the image of the application that you are looking to onboard. So you do that for the RF and you do that for the XApp, and then you have to deploy the applications into the network. So the deployment app, then if in the case where you have multiple instances of RIC platform, you need to choose where you want to deploy that XApp or RF. So here's the RF part now. Again, you specify the name for that particular application. You go through the same steps as with the XApp. Specify the descriptor. This is all following the ORAN standards. And again, the image is required in order to deploy the application. And then, in addition to this, there is a RIC UI dashboard which will show you basically the status of the apps, but also all the other status of policies that are being set by the RAP in particular and so on. So this is showing now the status of the apps that have been deployed in the network. Next.
Now coming to the use case with respect to the energy savings. So as I mentioned earlier, we have petabytes of data which we're trying to train from, and we're training from the millions of subscribers from a network with billion parameters of RAN, as well as on the elements in the network components as well. So why we are coming to the energy savings? Because as we know that we have a very good scope on the energy savings on the RAN segment, especially, as I mentioned, 30% or 25% roughly. This is the global statistics which I'm trying to mention here. So 30% of the macro sites are actually consuming 70% of the traffic. That's what the statistics says that. So still we have 60 to 70% of the cells needs to be optimized. The remaining cells are meant for the coverage perspective, meant for the regulations perspective. Those are the cells. So there's a big room for us to optimize those cells where we can have 80% of the energy savings will come into picture. We're still working on how we can optimize the energy on the RAN segment, but we are started with the basic steps where we can onboard our applications as a next step. Why we chosen these are the next step? Because from countries like Japan, US, and UK, kind of other global countries, like basically emergency calls are must needs to be addressed. We should not have any call drop with respect to the emergency calls. So maybe could be ETWS perspective or could be emergency calls perspective. So we wanted to have this application in the real time. The focus here is when the pattern says that, when my model says that, it doesn't need to have to operate high level, be it in 16 cross 16 in 5G perspective, 4 cross 4 in 4G perspective. So we can trim down to higher antenna elements to the lower antenna elements without impacting the coverage. But at the same time, I wanted to have my cell to be up immediately whenever there is an emergency call has been attempted. So there should not be any call drop with respect to emergency call. That's where we wanted to have this application closely into the XApp perspective, which acts in milliseconds, so that we never lose any customer or we will not lose any optimization over here. So we have trained this application. We have taken the inputs from the 3GPP measurements perspective. We take the periodic measurements, and as well as we will take the milliseconds from a 40 milliseconds to 80 millisecond measurement reports as per the standard, and we keep training our models. So if I see here, next slide please. So if I see how we are going to operate, let's see in the first diagram, which is on the left side, we're talking about there are a lot of users around where my model will not, try to optimize from 8 cross 8 or to 2 cross 2 or 64 cross 64 from the 5G perspective to 16 cross 16. So we don't want to limit our antenna elements so that you will not lose the throughput prospect. So, but whenever we see there is a room for us, because there are no significant amount of users, when I see this is the midnight or these late peak hours or off peak hours, where I can see there is a traffic consumption barely less than a couple of KBs or a couple of MBs, where my model kicks in and directs my XApp to decrease its MIMO configurations from 64 cross 64 to 18 cross 16 cross 16 as per the standard prospect. Then go to the next slide. So what we have done here is this entire XApp application, we are unique in the industry because it's not directly an XApp. It's a trained ML model which has been onboarded via RApp through XApp using A1 policy. Here you can see that the moment when we got an application, when onboarded the application, we have our policies has been registered over there. So we train our policies and has been onboarded via A1 interface, which is first in the industry that what we can say that. The policies will tell what are the parameters need to be configured, what are the configurations need to be taken into input, and also we consider what are the other cells where it would get impacted. So that's how the policies which we have implemented across in our platforms, and we can say that this first in the industry. Again, I'm saying that. Petrit, you want to add?
Okay. Key thing to take away here. So what the AI ML model is doing is basically using the data from the network to determine the traffic patterns experienced by different cells. So what traffic patterns do we have in the cells? That is the input to the RApp. And the RApp then is setting the policy via A1 to the XApp. The XApp uses that policy, which can be antenna down or antenna up. But it doesn't just use that to, switch antennas off or not. The XApp is actually monitoring near real-time traffic. And based on the policy, it will take the action accordingly. So if it sees those patterns occurring in near real time, based on the policy that the RApp has set, it will take the action accordingly. And when it does that, what we have demonstrated in the lab using a network emulator effectively is that you can generate up to 25% energy saving when you're doing that. Obviously, the energy saving will vary because the traffic pattern in the network will be very different across different cells. But on average, we see that kind of saving in this particular use case, which we have demonstrated. You can see that energy saving.
So one more important point which I want to drive here is it's not only the event policy, which we have implemented here. The key point is the conflict mitigation, which is one of the key modules in the RIC platform. So whatever the applications we have onboarded, being in XApp or app, which are actually driven through event policies, we have properly defined conflict mitigation policies. That again, it's trained models. So we have reinforcement algorithms has been implemented in the conflict mitigation, which is a unique source. So we cannot go and keep changing the policies. We cannot go and keep updating the policies as manually. So that's how we trained our models. That's how conflict mitigation has been trained in our system. That's how it is getting deployed in our network as well today. Yeah.
We've always had intelligence in networks, and what we have done, I think, artificial intelligence allows us to make much better decisions, as I said at the beginning. And one of the critical things with RIC, as Madhu said, is really streamlining those decisions and avoiding conflicts and making sure that the implementation is coherent. And those of you that have been working in those three know that we've had in the past lots of ways of making changes in the network, but we need to make sure that those changes are done in a controlled and intelligent way.
I will just clear, this is how our results are with respect to the 5G, which we have demonstrated in our lab. So based on the traffic predictions perspective, where we have trained the time series model, which has been deployed by our app and has been executed by XApp, where we see today 16R has been trimmed down to 88R. So where we can see the throughput perspective, it has been reduced, but the coverage definitely still maintained the same, but throughput hasn't come down because of the antenna elements configuration has been put down because of the efficiency perspective. So this is one more use case which we're talking about, trying to turn off the RF part for the small cells. So since we are a heterogeneous network where we have 5G macro, 4G macro, and we do have small cells, and we have pico cells and femto cells in our network. So we know in the commercial buildings as well as shopping malls where we doesn't need to have femtos or small cells to be operated 24/7. But the model, how it takes is we have samples from each and every corner of the particular building. So that's how we train our models. So we know these are the areas where the users are coming in particular office area or maybe the commercial space. And in the off-peak hours, we're trying to turn off these small cells. We're just turning off the radio off. But yes, still the CU prospect still it will be running. But when we see there is no requirement running the small cells 24/7 where there is no users in the off-peak hours, especially from 1 a.m. to 5 a.m., we can turn off automatically and we ensure that it having 100% coverage coming from the macro or from the 5G cell prospect. In that way, we are not losing any coverage at any given point in time, but at the same time, we're trying to achieve the efficiency of energy in this particular use cases. Yeah, so if I see, we have around a couple of small cells deployed in Japan. So when we did with this particular application in our network, so we have enabled for 70K small cells, out of which we have trimmed down to 56, basically in off-peak hours, trying to reduce the RF, and some of the cells we turn off the RF so that we are able to gain significant amount of power savings, approximately 8 hours per day per cell, which is equivalent to 27.2 watts. I mean, in the monetization perspective, roughly around 1 million yen we are trying to save per year perspective. Yeah.
That's really the end of the presentation. Just kind of a few key takeaway. The integration between AI and RIC. In fact, we see them as one entity that is very tightly coupled. So one allows you to make those decisions much better than we've done in the past. So that's what AI brings to the table. but you need to have control and ability to achieve that control over the network, making sure that there are no conflicts. That's a critical part of what Rick brings to the table as well. And this integration between AI and Rick and beyond just RAN is what is really exciting because I can see now that we're together with the cloud native network and what that introduces in terms of flexibility and scalability and the advances that we're making in AI. This is driving towards the zero-touch management and really autonomous networks, something that we have been striving for a long time.
Yeah. So that's what Petrit clearly mentioned about that. The same thing which we told earlier. It's not only limited to the RAN segment which we're trying to say here. We're also integrating other components from the core and other network elements, mainly coming from the NWDAV, integrating with 3GPP to O-RAN Alliance perspective, where we're trying to integrate these kind of solutions in our network and trying to deploy it to make our AIs more robust and more flexible, to bringing performance and user experience at Mark perspective. Yeah.
One last thing, I think for us as Rakuten Mobile, it's really important. I think it will be important for others in the industry that this use cases are implemented in 4G, not only 5G. Okay, thank you.
Thank you.